this class, we are going to discuss a topic on SNI reaction, that is substitution, nucleophilic, internal reaction we are going to discuss. In the last class, we had a discussion on, you know very well, that we had a discussion on SN1 mechanism and before that SN2 mechanism. Now in this class, the discussion is on SNI mechanism. Substitution, nucleophilic, internal mechanism, that is SNI. This is the one we are going to discuss now. Substitution, nucleophilic, internal. Internal in the sense this entire reaction takes place within the molecule. No need for the second reactant to carry out this reaction. Internally the mechanism takes place. Therefore this reaction is substitution, nucleophilic. The substitution is because of the nucleophilic, that is a nucleophile. Since the mechanism takes place within the molecule, we have a new word, internal. Substitution, nucleophilic, internal mechanism within the molecule. This is, name suggests that this takes place within the molecule. As I told you earlier, no need for the second reactant to carry out this particular reaction. Unlike what we have in SN2, nothing but that reaction is nothing but a bimolecular reaction. They require two different reactants. One is substrate, another one is nucleophile. And in SN1 mechanism, the next reaction what we had in the last class, there also we require two different molecules. Of course, the nucleophile is in the form of a solvent. Only one reactant we require. As per the kinetic calculation, just one reactant takes place in SN1. The second is nucleophile, that is in the form of your solvent. That is the reason why we arrived at a conclusion in the rate equation of SN1. Rate is equal to K, that is rate constant, multiplied by concentration of the substrate alone. Whereas in SN2, rate is equal to K multiplied by concentration of the substrate, and again multiplied by concentration of the nucleophile. Now in SNI, let us consider the equation between ROCl. I'm sorry, a small correction, SOCl. In the first step, this undergo deionize, that is dissociation, into S double bond O minus Cl plus, this is your step number 1. And in step number 2, R plus is there, S double bond O is there, Cl is already there, O minus is there. This comes here and this will be removed as Cl minus. This then directly attacks the substrate from the front side, that is from the front side. As a result, you will get a product with a retention of configuration and plus SO2. This is the reaction. So in SNI, this is the reactant we have taken to explain this particular concept, SNI, substitution, nucleophilic, internal. What happened, in the first step, ROSOCl undergo dissociation, that is ionization of the substrate into R plus SO2Cl takes place. This step is exactly same as that of your SN1 mechanism. In the SN1 mechanism also we had a dissociation of the substrate, that is the ionization of the substrate into corresponding ions takes place. In the case of SN1, same thing happens here also. In the first step of SNI is exactly same as that of your SN1, that is ionization of the substrate into corresponding ions, positively and negatively charged ions. And in the second step, what will happen? This O minus, the minus what we have over the oxygen will come here, converting the S single bond O minus into S double bond O simultaneously, because the sulfur will not maintain more than its octet electron in the outer shell, therefore it has to lose its Cl. Remember, this is part of the leaving group. This is part of the leaving group. This is completely a leaving group. In the first step, R plus SO2Cl is formed. This is the leaving group. And out of the leaving group that left in the first step, part of the leaving group, this is not complete leaving group, is going to attack your substrate. Only half, that is only part. The Cl is one part of your leaving group. The complete leaving group is this. Out of this, the complete Cl, that is your part of the leaving group, detaches from the rest of the leaving group, that is comes out of your rest of your leaving group, and this Cl minus now attacks preferably from the front side, that is from the front side of your substrate. As a result, the product you will get RCl with retarded configuration. No inversion of configuration, unlike your SN2 mechanism, where the nucleophile attacks from the rear side, from the back side. As a result, complete inversion takes place, and as a result we get the product with inverted configuration. Whereas here, there is no inversion, only the side from where the leaving group departs, from the same side, that is from the front side, the part of the leaving group detaches from the rest of the leaving group, attacks the substrate from the front side, As a result, you will get the product with configuration, that is a retention of configuration, no change in the configuration. This is what happens in the case of your SNI mechanism. See the board and explain. The concept is substitution, nucleophilic internal, and in short we have to write like this: S capital, N capital, and I small. I refers to internal because the mechanism takes place with internally. There are two different steps. Step number one is exactly same as that of your SN1 mechanism, where the ionization of the substrate into corresponding ions takes place. Here also RO, SOCl will be converted into its corresponding ions, R plus SO2Cl. And this one, in the next step, from this complete portion is your leaving group as per the step number one. And from the complete leaving group, only part, say for example the Cl alone is detaching from the rest of the leaving group, and the detached Cl minus now attacks your substrate from the front side. As a result, you will get RCl with retarded configuration, that is no change in the configuration. Configuration wise, retention takes place. And this is your SNI mechanism. What is SNI reaction? And followed by the mechanism of SNI reaction. We have more explanation on this, but since you are in the UG level, this is more than enough. Just in UG level, you may be asked to write what is SNI mechanism, or simply write down the mechanism involved in SNI mechanism. Nobody will ask you the evidences behind SNI mechanism and the stereochemistry behind SNI mechanism. Nobody will ask. Therefore, no need to worry. Just keep it in mind that what is SNI reaction. What are the different steps takes place in an SNI mechanism? What is the condition of SNI mechanism? In what way the part of the leaving group, how the part of the leaving group detaches from the rest of the leaving group, how this is attacking the substrate from the front side. These are the few points that have to be, you should keep in mind. And with this, I'm concluding the discussion today's class on SI mechanism. See about, try to understand what I have written on the whiteboard. Okay, we will meet you in the next class. Thank you then. Bye.